Welcome back to another episode of How to Algebra, where in this video we are looking at solving equations when the exponent is a power. So if you haven't done so already, subscribe, like, comment, let me know what you think, and hopefully you get something out of this. Let's get it. All right, solving rational power equations. Basically, when you have an equation with an exponent that's a fraction, there are two scenarios that you'll find yourself in. The first scenario, feel free to pause the video and you can read this, but the gist of it is that the numerator of the fraction is either going to be even or odd. Now, if the numerator is odd, that's the ideal situation because you can just use the reciprocal of the exponent and everything's going to work out fine. However, if the numerator of the exponent is even, then there's one step that you have to do. And basically, it's because when the numerator is even, when you use the reciprocal, it's basically like taking a square root or any even number root. And we know that when you have a square root or when you introduce the square root to the problem, you have to use plus or minus in front of the square root. And that's essentially what's happening. So it's being on the lookout for that numerator of the exponent, whether it's even or odd. So we have two examples here to demonstrate this. A couple of notes, right? You're going to basically solve the problem like normal, isolating the variable that has the exponent. You're going to apply one of these two properties, whether the numerator is even or odd, and then simplify for the variable as normal, and then in the end check your answer. All right, so here we have 5/9 x to the 5/3 plus 92 is equal to negative 43. So I'm going to isolate x, subtracting 92 from both sides. All right, so we get negative 135 on the right. I'm going to multiply by the reciprocal. 135 divided by 5, 27. 27 times 9, negative 243. Okay, so here's where it gets interesting. Because m is odd, I can multiply by the, or not multiply, I can raise this to the reciprocal. However, if I'm just starting out and I want to take things slow, I can raise it to the numerator first, right? Meaning if I do 1/5, the 5s are going to cancel. Fifth root of 243, negative 243. Well, because this is odd, it's an odd root, I can simply bring out the negative and everything's going to be fine, right? If you understand odd roots, the negative can be pulled out of the radical. So 243, when we factor this using our prime numbers, this is going to be 381, 327, 3 and 9, 3 and 3, and it's a fifth root, so I have to group together a group of 5. So the fifth root of 243 is just 3. Again, the negative's out front. And it's still x to the 1/3 power. If I cube both sides, cancels, making x is equal to, again, cubed root, so the negative can come out with no problems. And 3 cubed is 27. Let's see another example. 2 times x plus 5 to the 2/3 power minus 11 equals 7. So again, I'm going to start by adding 11 to both sides. So 2x plus 5, 2/3 equals 18. Isolating the x part, I'm going to divide both sides by 2. So x plus 5 thirds is equal to 9. Okay, here the numerator is odd. All right, so here the numerator is even. So since it's even, that means I'm going to have a plus or minus whenever I start solving this. So here we're going to take a power of both sides, 1/2 because of the numerator. So the left-hand side, this is going to be x plus 5, the 1/3 because that's what's left over because the 2's cancel. And this is equal to plus or minus 9 to the 1/2 power, essentially the square root of 9, which is 3. I'm going to cube both sides because of the 1/3 power. Left-hand side, this cancels. X plus 5 is equal to plus or minus 3 cubed. Again, odd number, so the negative can come out, or odd root rather. So the negative comes out. Actually, the plus or minus comes out. And this is going to be 3 cubed, which is 27. Subtracting 5, we're going to get x is equal to 27 minus 5, 22. And x is equal to negative 27 minus 5, which is negative 32. And essentially, we're supposed to check our answers. I'll leave that to you to go back and plug these in, but both of these work. All right, so hopefully you get something out of this. Be sure to check out the homework solutions and where you get more practice. Like, subscribe, comment, and I'll see you next time.